Somewhere in the universe, right now, a star is dying. Not slowly, not quietly. It's collapsing into something so dense, so violent, that not even light can escape it. We call it a black hole, and for decades that name was enough to terrify physicists. But in 2026, everything we thought we knew just got turned upside down. Scientists captured new data from the black hole at the center of our own galaxy, Sagittarius A star, and what they found inside the data was not what anyone predicted. Here's the thing about black holes. They're not just objects in space, they're breaks in the fabric of reality itself. Every equation, every law of physics we've ever written stops working the moment you cross one. And that terrifies scientists more than the black hole itself. Because if our physics breaks down there, it means we've been missing something fundamental about how the universe works. Tonight, we go in, deeper than any documentary has gone before, and we may not come back with easy answers, only better questions.
Let's start with what most people get wrong. A black hole is not a hole. It's not empty. It's actually the most concentrated form of matter and energy in existence. Imagine the entire mass of our sun compressed down to the size of a city. Now make it 6 billion times heavier. That's M87 star, the first black hole ever photographed back in 2019. Every black hole has three key regions. First, the accretion disk, that glowing ring of gas and plasma you always see in images. That disk is superheated material, spiraling inward at a significant fraction of the speed of light. It radiates X-rays and gamma rays so powerful it can sterilize entire solar systems within light years. Then comes the event horizon, the point of no return. Cross that invisible line and the escape velocity exceeds the speed of light. Nothing comes back. Not information, not time, not you. And at the very center, the singularity, a point of infinite density where space and time, as we understand them, simply cease to exist.
Here's where the story gets extraordinary. In late 2025, the Event Horizon Telescope Collaboration, a global network of radio observatories, released its most detailed image of Sagittarius A star to date. The resolution was so sharp, scientists could observe magnetic field structures near the event horizon in real time. What they saw challenged a core assumption that black holes are static, stable objects. Sagittarius A star was flickering, pulsing, displaying rapid magnetic reconnection events that released energy equal to millions of nuclear bombs in fractions of a second. Separately, a team at the Perimeter Institute published a landmark paper in early 2026 applying loop quantum gravity to black hole interiors. Their model suggests that instead of a true singularity at the center, there may be a quantum bounce region, a place where matter reaches maximum density, then rebounds. Not destruction, transformation. Some physicists went further. They proposed this bounce could be the mechanism that seeds new universes, our cosmos potentially born from the collapse of a star in another one. We may not be the origin of existence, we may be the aftershock of one.
Now, we arrive at the question that has consumed theoretical physics for 50 years. What actually happens to information, to matter that falls into a black hole? Stephen Hawking proposed in 1974 that black holes slowly evaporate, radiating energy in what we now call Hawking radiation. But here's the paradox that broke physicists' brains. If the black hole evaporates completely, where does the information go? In quantum mechanics, information cannot be destroyed. It's one of the most fundamental laws of physics. But general relativity says everything inside the event horizon is lost forever. Two laws, perfectly contradicting each other. In 2025, a collaboration between researchers at MIT and Caltech published new calculations suggesting that information is encoded in subtle quantum correlations within Hawking radiation itself, called the page curve conformation. In simple terms, the black hole doesn't erase information. It encrypts it, scrambles it beyond recognition, but never truly destroys it. Think of it like burning a book. The words are gone to you, but the atoms still carry the pattern. Theoretically, a being of sufficient intelligence could reconstruct it. The universe keeps its receipts, every single one. So, where does this leave us in 2026? We have better images than ever before. We have new mathematical frameworks. We have gravitational wave observatories, LIGO and its upgraded successor, LIGO India, detecting black hole mergers across billions of light years. Each merger sends ripples through space-time itself, tremors in the geometry of the universe, and we can feel them here on Earth. Scientists now estimate there are approximately 40 million stellar mass black holes in the Milky Way alone. We are surrounded by them. We orbit a galaxy whose heart is one. And somehow, life still exists, still thrives, still asks questions about them. Black holes are not the end of the story. They might be where the next chapter begins. Every question they force us to confront about time, about information, about the beginning and end of everything makes us sharper, more honest scientists. The universe is under no obligation to make sense to us, but it keeps offering clues, and we keep learning to read them. If this journey into the unknown sparked something in you, a curiosity, a question you didn't have before, then science is doing exactly what it should. Don't stop asking. The universe rewards the curious, and the most dangerous thing you can do is assume we already know the answer.